I directly picked up a application question. Okay, let's do one thing. What is asking here? There's a smaller sphere. There's a bigger sphere. So star it is. They are fixed here. The stars will not move, and the radii of them. Same diagram. I'm just putting it in order. The same diagram. Now we have this much here. So this is the radius A, radius 2A. There is a particle now. Mass of this we know 16 m. The mass of this is capital M. There's a particle of mass m naught. I'll write it. So with what speed it should be projected so that it can reach the surface? Minimum speed is asking. What is the separation? Center to center separation is 10A. So let this be the 0.1. Let me take it. This will be the 0.1. This is the, it has to reach 0.2. No? So what that minimum speed I should project. So shall we apply like a conservation of mechanical energy? Interaction potential energy at this point plus kinetic energy is equal to, because minimum speed is telling, so let it come to rest here. Then interaction potential energy of the particle with both the stars at this particular point. So shall I proceed like this? The interaction potential energy of the particle with both the stars plus initial kinetic energy given should be equal to interaction potential particle with both the stars when it is at 0.2. Conservation of mechanical problem will be solved. Okay, I think slightly you should really make observation here. So what are these are stars, no? Somewhere at a point P, I don't know, somewhere at a point P, shall I say the field strength will be 0? The field here will be directed in this direction. The net field and the net field here will be in this direction. Sir, how it is possible? Again, you have to go back to the point masses. If there are 2 point masses are there. Tell me like if M1 greater than M2. If M1 equal to M2, the field. So M1 greater than M2, the field will be 0 at point P. Will I agree? If M1 equal to M2, the field will be 0 at the midpoint. I think there's a concept. If you can accept this much, I think problem over. Or say that's what the maximum all numericals will revolve around the basic small ideas only. The field strength must be 0. So, or maybe 0, it must be 0. If M1 equal to M2 must be 0 at the midpoint. Similar situation is here, no? If masses are equal, okay, I would have said something. Since 16m and m, no, so I don't know, somewhere the field will be 0. Means now if you project a particle when it moves from 1 to P, tell me what type of motion? Retarding motion. Speed decreases. Somehow particle just reaches point P. Means if it just able to reach point P, after this what will happen? You need not do anything, no, on its own what happen? The net field will be towards left and it will accelerate. So therefore what I should do? If I project with a kinetic energy such that if it just reaches point P is enough, no? Afterwards it will accelerate on its own. I need not to do anything. The net field what happen will make it to accelerate further. So what is the type of motion from here to here? Retardation. Here accelerated motion. So what shall, from where to where I should project? This is the accelerated motion. Sorry, retarding motion. So if can just reach point P is enough, no? Because it's saying minimum. So I don't know that point P, what to do for that. So I'll calculate that distance x. So let me locate that one. So what is the net field at point P? Must be 0. I'll take it out this. It's a rough calculation. We'll do it here. It should be 0, or we'll write this one. So minus G16m by x square plus due to this will be, or if you take towards right positive, then you should take this as negative, or minus gm by 10a minus x whole square. Why 16m? Mass of this is 16m. I'm measuring the x from the center of this particular thing. The point P will be at a distance from the center of the sphere at a distance like that one. So this should be equal to 0. I think the GM will get eliminated. It's all about solving for x. Anybody? Quadratic equation, it will come. 10a minus x whole square equal to x is 16. This one.
Sir, 8 is sir.
X equal to 8, yeah?
Yes, sir.
Okay. Yeah, fine. This will be equal to x equal to 8a. So I am very sure that from here on, what is the data I got it? At x equal to 8a, the field will be 0. At 7a, the field will be towards right. At 9a, the field will be towards left here. 8a will come somewhere near to the point P. This one. Okay, now what to do after this? Okay, we got x equal to 8a, where the field will be 0. Here only I'll write it. Now tell me what after this. If it can reach point P, problem solved, no? Then I'll apply conservation of mechanical energy. Then in interaction potential energy when particle is at 1 plus kinetic energy K1 plus interaction potential energy of the particle when it is at point P plus the kinetic energy. Kinetic energy, what means? This should be 0. And there's a minimum. Okay, now interaction potential, how to calculate? The particle is there on the surface. Then what is the potential on the surface? That will calculate. So now interaction potential energy m0 into potential at point 1. Potential at point 1, what all? Due to both the spheres, no? So first due to sphere, I'll write it minus G 16m by 2a. And what is the potential at point 1 due to this sphere? Because what is the separation between them? 10a. In that, you take it 2a. So this should be equal to gm by 8a whole square. Try to see this. This will trouble you a lot. What is that u1? That u1 is what? What I calculated?
Sir, it's not a square, sir.
Okay, that one, yeah. This is a u1, no? Means, or else you can directly calculate potential at point 1. If you're finding out this one, m0 into v1. What is v1? Potential due to the bigger star and also due to the smaller star. Due to larger star and smaller star, due to both. So potential, the point 1 lies on the surface. What is the potential on the surface? So gm by a, here 16m mass minus g 16m by 2a. Potential at point 1. The point 1 will lie outside the smaller star. At what distance? At a distance 8a. So we'll put it here. So this, I think, I'll because like let's make very systematic. I'll write it like this, and it is projected with a kinetic energy V0 square by 2, Vp and 0. That V0 is minimum. What is V1? V1, let me calculate. Potential due to is it okay now? That V1 is potential and not a speed. Similarly, potential at point P. Potential at point P. The point P lies outside both the spheres, no? So it should be G 16mx. This will be Gm. It should be equal to how much? 10a try to look at the way we are calculating potential. Potential also, you can take superposition. Potential at 1 due to this larger sphere plus smaller sphere. Larger star plus smaller star. So can we take potential? Yes, potential at a point or due to how many bodies are there? Due to all that, you take algebraic sum. What is the idea from what is the idea? Suppose if there are 2 point mass are there, I want potential at point P. What you're going to do? Potential at point P. I'll write fair. Huh? Now this is at a distance x1. This is at a distance x2. Now what is the potential at point P? You're going to write minus g m1 x1 minus g m2 x2. Potential due to individual objects. As it is a scalar, so therefore nothing, no question of direction, no? Only just algebraic sum is what you have to take. Just sum. Same thing what we did here. Potential at point 1 due to larger star, the point 1 will lie on the surface, so minus g 16 by 2a. Point 1 will lie outside the small star at a distance 8a, so gm by 8a. Then point P will lie outside for both the stars. This is the formula. This value we are going to substitute here. Solving for V naught will get the required speed. I'll give the answer later on, you check it. So there's a use of that potential what we learned. See, my purpose is like the potential what all we learned now is going to help us a lot in problems of this kind. I'll write the answer later on, you check it. 2 gm by a. If you want, you can take the root 3, 6 gma 3 minus 1 by root 28. You can also write that one. So this is the answer. Agree this one? Let's go for energy of a satellite. Anybody wants to? I'll scroll down. We have plenty of numericals. There's unlimited topic because that is related to mechanics. No, there are around 50 to 60 numericals are there of different kind. So first, let me finish off all the theoretical ideas so that we can bring all ideas in one platform and we can work out many different numericals. Okay, I'll go for the energy of a satellite. Let me do it here. Will not come in order, no? Yeah, we'll do it. I will go for the satellite motion.